hey. And he's just like, hey. He's like, hey, nice fighter. Hey, you want to come to my house? And he's just like, everybody hates me. Just like,
hey, we gotta do this. Okay, off you go.
Did you mean to put 22?
Yes. Aaron, I'm gonna ask you that way, Smidge. Oh. Are we missing anybody today?
I'm gonna know it. Avery.
Avery. Okay, this is 6 hours.
For real.
Anyone else? Anyone else? No one else. Okay, sounds good. Hey, Cody, I'm gonna have you sit up here at this table, please. Okay? And I need him to sit on this side, right here. You want to shift to this side when you're doing some things on the board. All right, so I'm going to walk you through the science starter today so that we can kind of get going. I am recording this class because I've got some absent students and I think it's valuable that they have this information. So you remember scaling? Yeah, you remember scaling all the math and stuff, and we took our globe and we made our moon, right? And so our tinfoil moon is up there, and our globe is 12 centimeters across, right? So we're going to review that, and we are going to figure out the scale model size of a sun according to this. Cool? So to walk you through the procedure, you found your page 22, right? Well, what I want you to do is put your finger on the scaling factor for our Earth-Moon model. The back side of page 22, put your finger on the scaling factor. The number that is the scaling factor, the number. Put your finger on the number that is the scaling factor. You had your finger on it. It says scaling factor, and there's a number. Do you have your number? No, that's not the scaling factor number. Ah, you did your work here. There it is. It's right there. And then you wrote it again there. Okay? All right. So all at once, could you tell me what the scaling factor number is?
1063.
Okay. So we're going to transfer that to the back side of page 42. So everybody flip to the back side of page 42 and write this down just as I have it on the board. All right, scaling factor. And it is 1,063 mittens.
Meters.
Ooh, not meters, not centimeters,
Kilometers.
not kilometers. Check again.
Centimeters.
Look again.
Meters. Your attention, please.
No.
Choir, junior high choir students.
Look again.
They did not hear the bell in the room, so they will be a little late to this next class. Please, excuse me.
You should be looking on the back side of page 22.
Is it centimeters?
It is not centimeters. The scaling factor tells us how much it is in the real world per centimeter.
Kilometers in the
Millimeter?
millimeter per centimeters in the mile.
Yeah, you're right, Travis. Kilometers in the real world per centimeters in our model. Remember that? All right. So the next information that we need is the real diameter of the sun and the real distance of Earth to the sun. So you're going to use page 89 in the textbook to find those in that diagram. Put your finger on the radius of the sun. Put your finger on the radius of the sun in the textbook on page 89. Put your finger on the radius. You got one book. You guys, you two will need another book. Just grab one. Zach, Can you tip your book down so I can see where you're at? Yep. It looks like y'all have it. Okay, what is the radius of the sun? So I'm gonna say like real diameter of the sun, and so our radius is what?
695,000
kilometers. Thank you. Okay, but that's not the end of the story. If you look at this diagram here, okay, gotta check and see. Yep. Halfway is the radius, but we want the diameter. So what do we do to that number to figure out the diameter? We double it. So what do? Yep, we times it by 2. You guys have your big calculators out? Please figure out what that number is. 695,000 kilometers times 2 equals. This isn't going to work if we've only got 4 people with calculators.
139,000.
Kittens?
Kilometers.
It's one more zero. It's one more zero.
Is that not correct?
Oh,
Who
yeah.
else has a
No,
calculator?
it's
one more zero.
Yeah.
It's 1,390
No. Check your zeros.
with 3 0 or 2 0.
So that's not going to be 1,000. It's going to be
1,390,000.
Yep. Kilometers. All right. So write this down on the back side of page 42, just like I have it up here, please. Okay, and then I want to find the real distance of Earth to the sun. So I'm going to write that here. Real distance. Please put your finger on the column in the book that shows us the distance from the Earth to the sun. So now we're looking at the row that has Earth on it. And I'm going to maybe adjust this way a smidge. There we go. That's better. All right, so real distance of the Earth to the sun. You got your finger on it? Are you looking, Cody? Yeah? Perfect. What is that distance?
149,600.
Kittens? Kilometers. Okay. Does that make sense? Does it make sense? I don't know. 149,600 kilometers seems really close. Are you the only one that's noticed that today? Look at that column. Look at the label for that column. Columns go up and down in your book.
I know.
You have to times it by 1,000. Yep, so if I times this by 1,000, I do not need a calculator for this. I'm just going to slap 3 zeros on the end of it. So it will become 149 million. And then, 600,000. 000. Kittens. Kilometers. Yeah? Are we good on that? Fantastic. Now, if I want to figure out how big the sun will be in my model based off of the sizes we have here, with our Earth being 12 centimeters and our moon being 3.3 centimeters. Okay? Are you writing these things down exactly as I have them? Okay, great. All right. What am I going to do with the real numbers and the scaling factor? Yes, ma'am.
Divide them.
Yeah, I'm going to divide them. All right, so let's start with the real diameter of the sun. I'm going to take 695,000 kilometers. Nope, that's not right. I times it by 2. Sorry. I'm going to take 1,390,000 kilometers. That's the real diameter of the sun. I'm going to divide it by our scaling factor so that I can figure out, that's the real world per centimeters, how much each centimeter in my model is going to equal in the real world. All right? So, who's got a big calculator?
I do.
Do these numbers for me, please. Who can spit it out fastest? If you've got a calculator, you should be trying.
1,307.61994.
1,307.6, you said? Let's round that up. So my 7, since it's 0.6 after that, will round up to 8. 1,308. Now here's the kicker. What are the units? Zach, what are my units going to boil down to? Yep, this is in centimeters. All right, awesome. You have this work written down on the back side of page 42? Yeah? Okay. Underneath real distance, I need to add my model sun. Okay, and I kind of did this work in the wrong spot. So I need to make sure you have this work written down somewhere on page 42, and I'm going to erase it and move it down.
What is that for? What is that for?
This is my model sun. Okay, and I'm gonna erase this work and put it up here in a second. You guys don't have to erase the work. I need to make sure you have it down on page 42. Nod your head. I have it down on page 42. Okay. Going once, Isabel? You're good. Going twice? All right. So I'm just gonna do this, and so I'm gonna label on here model sun diameter equals 1,308 centimeters. Okay, and so I wrote that up here, and now I need to figure out my model sun distance. Yeah? All right, so what do I do? Carson, how do I set up an equation to figure out my model sun distance? Have we timesed it all today? Nope. What did we do when we figured out the real diameters, the model diameter sun? What did we just do? What did we divide? What is it that we divided? What number? Not the actual number, but what did that number represent? You can look on your paper, like you wrote down the work. We took what and divided it by what? $1,063. We divided the real diameter of the sun by, which is the scaling factor. So to find the distance, what do you think we do? No. To find our model diameter of the sun, you said we took the real diameter of the sun and divided it by our scaling factor. So now to find the model distance, what are we going to do? No. We're going to take the real distance and we're going to divide it by the scaling factor. Because what we're trying to find is the model distance. Yeah, let's do it. All right, so I'm going to take my real distance, which is 149,600,000 kilometers, and we're going to divide it by our scaling factor, 1,063 kilometers in the real world per centimeters in our model. And so raise your hand when you have the answer. I got 4. Anyone else got a calculator doing the work? If you have a calculator, get it out now. That's it? All right. Ella, what do you got?
140,733.7.
Okay. 140,000. Yeah. 733 point.
7723.
Okay. 73. We'll round this up to 4 since the decimal was 0.7. It will bump it up to 4. Okay. And what's my unit? This is for our model. What's my unit for our model? Yep, because these cancel each other out and we're left with centimeters for our model. Great. All right, I'm going to transfer that up here so that I know what the heck this number means. All right. And now, you wrote all this work down? These are pretty big centimeters. Let's convert these into meters. So I've got my meter stick, right? And there are 100 centimeters in a meter stick, right? So 1, 2, skip a few, 99, 100 centimeters in my meter stick. I want to know how many meters with this many centimeters. So an easy trick is, well, 100 has 2 zeros behind it. This number is going to get smaller. So I'm going to take my decimal and move it back 2 spaces, which means how many meters am I looking at if I take my decimal and move it back 2 spaces? I got one person who knows, 2 people. 3.5, 4. Dylan, what do you think?
13.8.
Yeah, we're going to go with just 13. 13 meters. Now, I've measured this room. 13 meters. This room from that wall to this wall is 10 meters. That means the size of our model sun to our Earth is bigger than this room. Yeah? Does that make sense to you? Because if you remember our activity from yesterday and we used the Skittle compared to the exercise ball. Okay, so that makes sense. Now let's figure out the distance. 140,734 centimeters. If we convert that into meters and we move the decimal back 2 spaces, what does it become? Everybody say it.
1,407.
Meters. Okay, great. And then I can tell you this. There are 1,000 meters in a kilometer. 1,000 has 3 zeros. This number is going to become smaller, so I'm going to move the decimal left by 3 decimal spaces. What does that become for kilometers? 1.4 kilometers. That means if the room is our sun, our Earth model has to be chucked 1.4 kilometers away in order to represent the distance from the sun to the Earth. Does that make sense? Yeah? Did you copy all this down? I'm about to erase it. We're going to change gears. We're going to figure out a different model. Our different model is going to be this. We can't really create something the size of this room and do all the planets, right? Because we would be like going out and out and out. So instead, this is going to be our sun. Can you see what this is?
Dime.
It's a dime, the smallest coinage in the United States, right? It's a dime.
That's smaller than
Sure is. Yeah. Okay, so we've got our dime. I'm going to erase this. You're going to draw a line underneath the work that you did on the back side of page 42. And we're going to figure out a new scaling factor based on this dime. All right. So we know the real diameter of the sun, and we know the real distance from Earth to the sun. What else do we want to know to make a model solar system based on this being our sun? Yes, ma'am.
The real diameter of all the planets.
Yep, we want to know the real diameter of all the planets. We'll get there, but we're basing it off of this. So what do we need to know?
the diameter of that.
We need to know the diameter of that. So you guys need to write scaling factor. Look at you. Underneath that line, write scaling factor because we're figuring out a new scaling factor. I'm going to leave my scaling factor here. You guys will use this information again from the top of your page, okay? And then underneath scaling factor, you guys need to write model diameter sun, and then I'm going to say this is our dime. Now this kept me up at night. I'll explain why in a little bit, but I measured the diameter of this dime like 5 times yesterday because I was irritated. I'll let you know why, but the diameter of this dime is 1.7 centimeters. And I'm going to put a little m after that to signify that's the model size. Copy that down as well. Now, how do we find the scaling factor? I want to know what 1 centimeter is equivalent to in the real world. So if you think back to what we did before, you can look back at page 22. If you think back to what we did before, how am I going to figure out the scaling model? Some people are even looking back. That's awesome. Cade. Yeah, you would. Absolutely. So what I'm going to do is I'm going to set up my equation like this. I'm going to say 1.7 centimeters for my model is equal to the real diameter of the sun, which is 1,390,000 kilometers in the real world. Okay? And then Cade said, I'm going to divide this number by that number. Here's why. I want to make one side equal to 1. So I can make this side equal to 1 by dividing it by itself. And then I divide this side by the same thing. I'm reteaching this because this is going to show up on your next test, which we're looking at on Monday, Tuesday of next week. Okay, so you need to know how to figure out the scaling factor again. So I'm going to make my equation equal to, you wrote this down on the back side of page 42? If you didn't, do it now. All right. So who's got a big calculator? 1,390,000 divided by 1.7.
817,647.
Ah, kittens, gremlins, shoes. No? The real question is, what is our scaling factor? Remember, we want to know how many kilometers are equivalent to 1 centimeter in our model. And if you look at the work you did, because I know you labeled your work because I'm teaching you right, we are looking at this, and this line is really important. What are we doing? What is our unit? Macy, what's our unit going to be? These cancel out. Where'd the centimeters go? Did the centimeters cancel out? No. So what do we need to do? If kilometers are still there because they don't cancel out, and centimeters are still there because they don't cancel out, what do our units need to be? So the kilometers didn't go away. Remember, we want to know how many kilometers are represented by 1 centimeter in our model. So our units need to be both of these. How am I going to write it?
Kilometers, real, centimeters.
What do I put in between them? That line means per or divided by. Have you ever heard of miles per hour? You will, because you'll start driving more, right? Watch out, okay? This is kilometers in the real world per centimeters in the model. That's our whole unit for the scaling factor. So I'm going to transfer this number up here. You guys do it too. 817,647 kilometers in the real world per centimeters in our model. And then this is going to go away. Does anybody need me to keep this up here? Going once. Going twice. Okay, I'm going to erase it. Now, that's fantastic. We figured out the scaling model. I want you to flip to the front side of page 41. Here's the front side of page 41. And you see the column where it says Model 1 centimeter equals 1 million kilometers? How the heck did they get that number? Because you know what? In our model, 1 centimeter does not equal 1 million kilometers. 1 centimeter equals 817,647 kilometers per 1 centimeter. Let me show you what they did.
They're doing meters.
No, they're not. They're doing kilometers per centimeter. Okay, here's what they did. They took this number, see this, 1,390,000, and they rounded. Don't write this down. I'm just going to show you because it's irritating. 1,400,000. They rounded. They said that's the distance, or that's the sun's diameter about. And they made it equal to, get this, they measured their dime, a U.S. minted dime, they measured it at 1.4 centimeters.
Wow.
What? Want to know why? Look what happens when you do the math. That cancels out and we get 1 million. Meh. So all they did to get that number was round. We're not going to do that because that's stupid. So I want you to do is cross off 1 million. The front side of page 41, cross off 1 million. And write this number in instead, 817,647. Cross off 1 million. No, thank you. And write 817,647. Now, using this scaling factor, we can then determine to scale what the diameter of Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune is supposed to be according to a dime size. Imagine Mercury. If the sun is as big as a dime, how big is Mercury going to be? Microscopic. Okay, let's do that. So for your planet, write Mercury. This is on page 41. For the first planet, write Mercury. Go find the planet radius on page 89. Write that in there. Then somebody tell me.
2,440
2,440?
kilometers.
Thank you. 2,440 kilometers. And this is Mercury. Whoops.
Times it by 2.
Yeah, so that's the radius, right? If this is the radius, you times it by 2 to find the diameter. Go ahead.
4,880.
4,880? 4,880. That's perfect. Oops, that's not a 6.
So that's the planet radius?
That's the planet diameter. You just told me what the planet radius was. It was 2,440 kilometers. Then we times it by 2. Now the planet diameter is 4,880. So now you have the first 3 columns filled in for Mercury. Now go ahead and write in the distance from the sun. Okay, and remember to add 3 zeros onto that number that you see for Mercury. We're looking on page, you need your own book? Get a book. Pause. This is not homework. This is. You would have started this with the sub. Read page 54 to 57. Take notes, then answer. Explain 4 ways. Stop. Stop. Explain 4 ways gravity affects the behavior of objects throughout the universe. This is, along with the pages, PDFs, up on the Google Classroom. You can either borrow the books, you can either make copies, or you can look on Google Classroom to do the reading, take notes, and answer that question. Everybody good? Thank you.